All right, guys, we're going to go ahead and get started. It is the 22nd. It's Thursday. You're supposed to have out notebooks, calculators, and pencils. So this problem says, do these tables represent a proportional relationship? So that proportional relationship, that word, that phrase, this is what we've been talking about kind of all week. So do these tables represent a proportional relationship? So if you guys remember, we have a formula for proportional relationships, which is K equals Y divided by X. It can also be written as Y equals KX. These are the same formulas. We've used them. Make sure they're in your notebooks. Maybe you can write proportional relationship or constant of proportionality, because we have talked about K is representing the constant of proportionality. And what, oops, sorry, it's hard to write on this thing sometimes. So what that means is K is going to be a constant relationship or ratio between numbers. So we want to figure out if these tables represent a constant of proportionality or have a constant ratio or rate of change. So I'm going to look at table 1. So I'm going to label this table number 1, and then we've got table number 2. So I want to know if these are proportional relationships. So time in minutes, this is going to be our input, our X, and distance in feet, that's going to be our Y, our output. So if I'm looking back to our constant of proportionality formula, I'm going to take Y divided by X to figure out the change. So if I take 4 divided by 0, so I'm going to take Y divided by X. And I don't know if you have ever had this experience before, but when you divide, so I'm taking K equals 4 divided by 0. If you put that in your calculator, you get a thing that says error or divide by 0. You cannot divide anything by 0 because that's taking 4 groups of something and dividing it by nothing. So it's or 4 of something and dividing it by nothing. So we actually can't even do that. So that is actually not even possible. So this relationship right here, we can't even represent it. However, just to prove that this isn't proportional, this table number 1, I'm going to take K equal, I'll start with, or I'll go to the second one. So I'm going to do Y divided by, so 10 divided by 2 is going to be our Y divided by X, and that gives me 5. Well, if I do 4 and 16, if I do that point, I would be taking 16 divided by 4, which gives me 4. So these numbers are not the same. And if they were the same, that would mean we have a proportional relationship. But because they are not the same, that means that table number 1 is not proportional because these numbers are not changing at the same rate or ratio. All right, if we look at table number 2, we've got time and minutes again. So we've got just a table. We've talked about representing things with tables. I'm going to look at point number 1. All right, so 0 divided by 0, that's just at the origin. So if we remember, 0.00 is just going to be at the origin. So if we're talking about a graph, that's going to be the point right here, 0, 0 on a graph. So I'm actually not going to compare that. But then if I go to 2, 6, so if I look at 2, 6, so this point, remember we've got X and we've got Y. I'm using this formula, this constant of proportionality, K equals Y divided by X. So I'm going to do 6 divided by 2, and that gives me 3. So for this, the rate of change or the constant of proportionality is 3. Now I'm going to go to 4 and 12. So I'm going to take 12 divided by 4, and that also gives me 3. So the rate of change between these numbers in this table is the same. And if I look at 6 and 18, well, 18 divided by 6 also would give me 3. So table number 2 is proportional because it does start at 0, 0, and that relationship is changing at the same ratio or the same rate. They have the same constant of proportionality. And I know this is a lot, but we're going to do some review today. We're going to go over a bunch of different skills. So I just kind of wanted to wake our brains up and kind of start thinking stuff through. All right, so a recap. This week we talked about what is a proportional relationship. We've made connections between tables, graphs, and equations. So we talked about how we can represent a relationship with a graph, a table, and an equation. We've talked about rate of change, and then we also talked about K as a unit rate, meaning that if we see a table and we've got X and Y, we're kind of, K is representing what it changes at a certain rate. So if I have like 0, 2, or let's do like 1, 2, 2, let's see, 4, 3, 6. That is changing at a, so 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, so our K would be 2. So it's changing at the same rate. So K is representing a unit rate, which means that K, our equation for K in that instance would be Y divided by X, so 2 divided by 1. And remember, anything divided, so when we're looking for unit rates, we've kind of discussed this earlier this week, so I'm trying not to kind of go all over the place, but a unit rate is like the price per one, miles per hour, anything per one. So that K is representing a unit rate, that relationship for every 1 unit. So this is saying that our relationship of K here is moving at, that's the unit rate. So K equals 2, or K equals 2 over 1, which is a unit rate. And we'll talk about this a little bit more. We'll go over more examples. This isn't necessarily going to, this is just a concept that I want you guys to start understanding. This isn't necessarily something that's going to be quizzed, but I do want you to start understanding what a unit rate is, and then understanding how K acts as a unit rate. All right, so we're going to go ahead and do a recap of the week. So representing proportional relationships. So we want to find the constant of proportionality for the tables below. So we know that K equals Y over X, and another way we can write that same equation is Y equals KX. So those are the same exact equation. We kind of talked earlier this week about Y, but just make sure you have both of those written down next to the word or the phrase constant of proportionality or proportional relationships, because K represents that constant of proportionality that we see in this problem. So we want to find the constant of proportionality. All we have to do to find the constant of proportionality, it sounds like a fancy term, but all we're really doing is taking 3 divided by 2, 4.5 divided by 3, 6 divided by 4. So we're taking all of our Y values and dividing them by the X that's associated with them. So 3 divided by 2, and again, I'm doing Y divided by X. So 3 divided by 2, and I can use my calculator because that's going to give me a decimal. 3 divided by 2 gives me, I don't have a lot of room here. It gives me 1.5. If I take 4.5 divided by 3, that gives me 1.5, or I already can tell that I have a trend, but I just want to check with the third value. 6 divided by 4 gives me 1.5. So our constant of proportionality here is going to be 1.5. This being said, we can write K a few different ways. So we can either write Y equals 1.5x, that can be our equation, or we can write 1.5 equals Y divided by X. So all I did was I replaced K, because remember K is our constant of proportionality. That's what that K represents. And I just replaced whatever K was in both of these equations with 1.5. So to find the constant of proportionality, all you have to do is take Y divided by X. And if it is the same for several different points, then it is proportional. All right. Phil is riding his bike. He rides 25 miles in 2 hours. 37.5 miles in 3 hours, and 50 miles in 4 hours. Find the constant of proportionality and write an equation to describe the situation. All right, so I can already tell I need to set up a table. So go ahead on your papers, so on your, in your notebooks, go ahead and write, we're gonna draw out a table together. So I just wanna know, and we're gonna work on finding the constant of proportionality. So I'm gonna highlight some important information. I know that he rides 25 miles in 2 hours. He rides 37.5 in 3 hours, and 50 miles, whoops, he rides 50 miles in 4 hours. So what I'm going to do now is I'm going to write these in my table. So my X is going to represent miles. I'll write that over here, miles. And my Y is going to represent hours. All right, actually, I'm sorry. Wait, let me think. If he's writing 26, my bad, guys. I'm sorry. My brain is a little bit foggy today. We are going to write miles here. Sorry, miles and hours. Sorry, I didn't mean to mess you guys up there. All right, so we're going to look at the one in yellow first. So he rides 25 miles in 2 hours. He rides 37.5 miles in 3 hours. He rides 50 miles in 4 hours. And if you're wondering why I made hours X and miles Y, it's because I want to figure out what the constant of proportionality is. So I want to figure out how many miles he rides in 1 hour. That's what K is going to mean. So remember we talked about that unit rate, that per one. So we're going to be talking about what the unit rate or the K or the constant of proportionality would be for this one. So remember, to find what the constant of proportionality is, we're going to do K is Y divided by X. So I'm going to go down a little bit. So I'm going to take 25, make sure you're with me. So in your calculators, 25 divided by 2. So I'm just going to, so we've got 12.5. Oh gosh, what am I doing? 12.5. For the next one, we're going to do 37.5 divided by 3. And we've got 12.5. All right, and then 50 divided by 4 is also going to give me 12.5. So what this constant of proportionality means, this means that in 1 hour, he rides to 12.5 miles. So that is going to be K as a unit rate. So find the constant of proportionality. So in this case, K is going to equal 12.5. So we want to find, we want to write an equation. So remember, we can write our equation as Y equals K times X, or K equals Y divided by X. I'm going to go ahead and pick this one. So I'm going to do Y equals KX. So Y equals K is our constant of proportionality in X. So what this equation means, this means that I could really plug in any value for X or any value of Y. So if I was writing, so remember, X is hours. So if I wanted to figure out how far Phil rode in 5 hours, I could plug in 5 for X and figure that out, figure out how far he went. So that's kind of what that means in this situation. And I know it looks like a lot, but we, with practice, we'll get it. In finding the constant of proportionality, all you really need to know is take Y divided by X, and that's how you can find the constant of proportionality between numbers. All right, so we're going to get into slope a little bit more next week. However, we have briefly discussed the rate of change formula, and we're going to review it much more next week. So let's see if I have anything else that I wanted to, all right, we will do this one. So this says find the slope of each line. So we, next week, we're going to talk a little bit more about how rate of change and slope are the same thing, but we have actually already reviewed what the rate of change formula is. And if you guys remember, it's going to be y2 minus y1 over x2 minus x1. And that's going to give you the rate of change in a line or in a table. That just means the rate in which a line is moving. So we want to find the slope of each line. So the first thing we're going to do is we're going to pick 2 points on the graph. So if you have graph paper, you can practice graphing these, or you can just watch me for right now. So it does pass through the origin, so it is proportional. but it is a straight line. So I'm going to pick these 2 points. So we need to make sure, before we can start doing anything, we need to identify those points. So I'm going to have A and B. So point A is at 0, 0. So point A is 0, 0. Point B is at, so over 1, so X is 1, and it's up 1, 2, 3. All right. So we've got these two. What we need to do is so Y2 and Y1. So we need to take the Y's from both of these. So I'm going to go ahead and do Y2 is going to be 3. So Y2 minus Y1, which is 0. And then over X2 minus X1. So 3 minus 0 is 3. 1 minus 0 is 1. So the slope or rate of change is going to be 3 over 1, or 3 divided by 1 is just 3. And we're going to practice this a ton. So if it's not making sense yet, do not worry. We're going to do this all next week. I just kind of wanted to review. We did introduce this week, but this the rate of change and slope is not going to appear on your homework this week. And I'll kind of talk about what next week looks like at the end of class today. I'm actually going to move on because I do want to get through a few more things. Unit rate as slope. Let's see if I have anything else. Let's see. Why did I include a bunch of stuff about slope? All right, we're going to do these. So we've got, we'll go back to the slope stuff. I did want to kind of reiterate, though, the constant of proportionality stuff. So this says write an equation relating the variables in each table. So we've got time x, distance y. So this is saying, so in 15, whether it's meters, miles, so at 15, they travel 1 minute, I guess. So in 15, we'll just say in 15 miles, it takes 1 minute to travel. In 30 minutes, it takes them, or in 30 miles, it takes them 2 minutes to travel. So write an equation relating the variables in each table. So I'm going to find the constant of proportionality. So y divided by x, okay, equals y divided by x. I'm going to start by doing 15 divided by 1. So 15 divided by 1 equals 15. 30 divided by 2 gives me 15 as well. So on and so forth. We'll just do one more to make sure. 60 divided by 4 also gives me 15. So our constant of proportionality is the same for all of these. So that means that our constant of proportionality is 15. So we need to write an equation. Remember, we've got this equation over here, but we've also got that y equals kx. So since k is 15, our constant of proportionality is 15, I'm going to go ahead and write for my equation, I'm going to write y equals k, which is 15, x. So that's going to be our equation. So this means that we could plug in any of these to figure this out. So we could plug in any number for x. So if we wanted to figure out how far they went in 7 miles, we could plug in 7 for x, that kind of thing. All right, over here on the left, on the right side. So this is saying we travel 6, we'll just say 6 miles in 16 minutes. So we want to figure out what the constant of proportionality is. So I'm going to divide, again, k equals y divided by x. So I'm going to take 6 divided by 16 equals, and in the calculators we can type that in. So 6 divided by 16 gives us 0.375. All right, I'm going to go ahead and do 12 and 32. So 12 divided by 32 gives me 0.375. So I can already tell that my constant of proportionality is going to be 0.375. So the rate in which it is changing is 0.375. And if you guys can remember, we talked about unit rates a little bit. So this 0.375, this means that, and I'm trying to, so K equals, so they're going to travel 0.375 in 1 minute or whatever. So the unit rate is going to be 0.375. So distance, I hate that these don't have units. I'm going to do miles. Oh gosh, that looks terrible. I'm sorry. I'm supposed to say miles and we're going to do minutes. So K equals however many miles. Remember, K equals Y divided by X. So it represents that we would travel 0.375 miles in 1 minute. So that is what that K means. That's what I mean when I'm talking about a unit rate. So K is a unit rate. It is the rate in which these are changing and jumping. All right. So K is 0.375. So our equation is going to be Y equals 0.375 X. And I could plug in any time, so any number of minutes, I could plug that in for X, and I could get that's the formula for Y. So I could find Y that way. All right, I know there's a lot going on right now. If you guys have any questions, you can unmute yourself or put them in the chat at any time. I will be looking at that. I know this is a lot. This is a lot of review. That's kind of why I'm blowing over some things. This one's a little bit harder, so we're probably gonna, depending on how long this takes, we'll wrap up class in a few minutes. A Canadian goose migrated at a steady rate, I already see the word rate, of 3 miles every 4 minutes. So in 4 minutes, that goose traveled 3 miles. All right. So we want to fill in the table. We've already talked about how to find that constant of proportionality. So K equals Y divided by X. So to figure out what that K is or what those remaining values would be, we're going to go ahead and use that formula. So Y is 3, so I'm going to find the constant of proportionality by using this point right here. So I've got 3 divided by 4 is going to give me K. So K equals 3/4. That's all that means. So all I have to do now is, so 4 times 3/4 gives me 3. So now I'm going to do in my calculator, I'm going to do, and also guys, 3/4 is the same thing as 0.75. So if you would rather use a decimal, you guys can also do that if your calculator doesn't have a fraction function. Okay, so we're going to take 8 times 0.75 or 3 ABC4. It's up to you guys. And we're going to get 6. All right, now we've got 9 in the Y spot, so we're going to actually divide to get the answer for that one. So we're going to take 9 divided by 0.75, and that's going to give us 12. I'm already starting to notice the relationship with these two. For every 4 that this jumps 3. So kind of start noticing relationships like that to check your work and check yourself. So right now, this is the equation that we're using. So if you guys are confused, I know it's harder because I'm not teaching you guys in person, so I can't point to the board and different stuff in the room. But right now, we're using the formula Y equals 3, oh gosh. So you can either write 3/4 X or Y equals 0.75 X. So when we've got Y value, when we plug it in for Y, so like for example, 12, we need to divide both sides to get X, because we need, so if we have 12 equals 0.75 X, to get X by itself, we would divide both sides by 0.75. And I know that looks like messy, but so in our calculators, we're going to take 12 divided by 0.75, and that's going to give us 16. And then finally, for 20, we're going to go ahead and do 20 times 0.75. And that's going to give us 15. Whoops, maybe 15. All right, so we completed the table and we described the relationship. So y equals 3/4 x. Graph the relationship. So this wants us to graph. So I'm going to go ahead and I'm going to plot the points. So we've got 4, 3, so distance. So every 1, 2, 3, 4, 5. So every notch represents 2. So if I'm going 3, I'm going to go over 1, 2, because that's really 3, and then I'm going to go up to here. So this is going to be 4, 3. Then I'm going to go over 3 more. So I'm going to go over 1, 2, and then I'm going to go up 2. And it's really hard to do it on here and not show you guys on like a document camera or on graphing paper. We'll get more. I'll use some more tools to help you guys, and also I'll show you a few things at the end of our lesson on Google Classroom. So if we graph this line though, what I'm trying to say is it is going to be a straight line, and then it wants us to find the slope of the graph. I want to kind of save slope for next week, because I know we talked about it a little bit with this problem, but I want to start talking about slope a little bit more next week. So what I wanted you guys to get out of this week is to find a relationship between numbers. So from a table, from a graph, from an equation, and I wanted you guys to be able to understand what the constant of proportionality is. So the constant of proportionality, this is the formula. If we can figure out the ratio between y and x, that's going to be the same every time we jump between numbers. All right. Okay. So last thing I'm going to do is I'm going to show you guys your Google Classroom page. All right. So we are remote CP math. If you click on classwork, this is your Zoom link you use every day for class. I organize everything by week. So this is this week. This is our last lesson of the week. We have lessons Mondays through Thursdays. Fridays, I will be here if you want extra help. If you have a question about anything, I will be on. So to access that help session on Fridays, you're just going to click the same link you normally would around this time. And then I will be on that entire time if you want to ask for help, do a practice problem, something like that. Also, if you missed a lesson, we've got all of our lessons that we've done thus far, and everything with an exclamation mark is something that is due for credit, or points. So this week you have 2 things. You've got the intro to proportional relationships, and you've got an exit ticket. And all of these are just checking, doing a quick knowledge check. Do you understand what a proportional relationship is? And can you identify a constant of proportionality, that kind of thing. So that's all we're doing this week. Next week, we will be talking about rate of change in slope. So be ready for that. That's what's coming next week. So these 2 things, the exit ticket's due tomorrow, and the intro to proportional relationships is due on Sunday. So just make sure you get those 2 things done. Email me with any questions that you guys have, as well as I'm going to stop recording the video now. Let's see.